Okay, good evening, everybody. So today is April 8, 2021. So we are on week 12. So we see that we are on almost at the end, the last quarter of this course. Okay, we have just a few more topics. So today we will discuss thread, multi-threading, and parallel programming. So actually, I discussed this in a previous class, maybe 2 or 3 lectures early before I started it. Okay, so just let us recap it quickly. So thread is, what is a thread? Thread is an execution path of program. Like when we drive on a way, on a roadside, right? There are multiple lanes, right? One is maybe incoming, another is outgoing. There are maybe multiple incoming, outbound or inbound in freeways, right? So each of this lane is kind of is a thread. In real life, is a lane is a thread. Okay, so a thread is a program execution path. So far the programs we discussed so far is single threaded programs. It has the main thread. Okay, only single lane, single line. Okay, so but it is possible, and sometimes it is needed multiple threads, especially okay, in order to process distributed data or doing parallel or concurrent computing. Okay, so that means if you have data in multiple sources, okay, and then you need to collect data from multiple sources, then what you can do, there are different ways that it's called distributed data. So you can run your program in multiple ways. So for instance, multiple threads. For instance, if for every incoming thread, there will be data coming, and then your program will be processing data. And then finally, at the end, they will merge the result. So the concept is fasting to make the program execution faster. Okay, so far the program we discussed, that is called main thread, main method. So in standalone programs, all standalone programs have the main method or main thread. Okay, so but in parallel programming, there may be multiple threads. So in parallel programming, what is the concept? We divide the programs in sub-programs, and we solve the programs, sub-programs, and then after that we merge the result. Okay, so only thing that for parallel programming, it is needed. It is nice to have multiple processors. Now in modern computers or laptop, you see that there are core processor, multiple processor, co-processors. Some of the processors are used for dedicated for special purposes like metric operations, arithmetic operations. Okay. So now in modern computers, almost all computers have at least 2 processors. So then it is possible to have multiple, more than 2 processors to process data. But so the in-depth of parallel processing is not the concept, the topic we will discuss in this course. So just we will give you some idea how it is possible to create multiple threads and run the process concurrently. Okay. So there is a little bit difference between concurrent computing and parallel computing. So in parallel computing, a task is broken into subtasks, and the solution to the subtasks are then combined to get the final result. Okay, and concurrent processing computing is the task may not be related but done at the same time. So there is a minor difference between parallel computing and concurrent processing. Okay, so in the parallel processing, the tasks are related, and then tasks are divided into subtasks. But concurrent processing, the task may be different. Okay. And distributed computing or distributed processing is there where data coming from different source and result are sending in multiple sources, different sources. Now at the era of cloud computing, so distributed computing, parallel processing, concurrent processing, these are more popular and are being used widely. Okay. So these are some questions. So if we have more than one processor or core processor on the CPU, can we leverage them for multiple for parallel processing? Can we really run run multiple things in the same place to speed up our? That depends on the situation and data. Okay, so actually parallel computing and then concurrent processing, especially parallel processing, we say that, or multi-threading proportion. These work for large program. For a small program, it may not be effective. Okay. So, for instance, if I ask you to bring a pen or pencil to me, if two people try together to bring the single pencil to me, right? It will be more. It will take more time. Rather, a single person can bring a pencil quickly, right? You understand concept? So it's not the concept that always parallel processing will work, will be faster. It depends on the data. If it is large enough, then parallel processing is working. But we will consider that our data and program are large enough. So in this, like in my regular this computing setup, we will not have enough data or enough setup to really to play with a large amount of data. So, but we will demo the process with small data, small concept. Okay. So whenever you take your senior level courses for parallel computing, then you will learn that. Or distributed processing, you will learn that. Okay. So now there are in our last lecture we discussed there are two ways to create a thread. Okay, I will come back here. So there for every thread there are 5 stages, four or 5 stages actually. We'll discuss that. So let me show you how to do a create a thread. So in Java there are different ways to create a thread. One just create a thread by inheriting the thread class. That means extending the thread class. Another way is to implement the learnable interface. So interface, we do implementation, right? We implement interface, and by what we extend class. Okay. So at least if you learn this, and the second one is more likely with C#. Okay. And either way, your class needs to have a run method. Okay, we will discuss this one, and then this is in C# or some other languages like C#, we create a method. Then we create a thread pointing to that method. So we will come soon how to create a thread. So in Java, so we implement a runnable interface. So that means it creates a dot class, okay, with its own thread. Okay, and then you see that these are simple, right? These are the fields, class field. Everybody is familiar with this, right? Okay, so we made it as a static because we want to maybe keep keep track of how many objects are being created. And this ID, it has ID, it could have name, other attributes. Okay, and this is the dog constructor. Whenever we create a dog, I think we can increment the counter, and we can assign that counter value as ID. Okay, and this is the run method I was talking about. This run method is used to run. It has like 1000 dog instances. Okay, so this is the class, just dog class we created. So you remember that previously we created just single simple dog class without this code, without this. Without like this code. Okay, without this, it will be a single simple class with single thread. Okay, so but it will be multi-threaded programs. So now let us go. So here, if we say dog object d1 equal to new dog, and dog object dog d2 equal to dog object d2 equal to new dog. So now here we see that. So we will create thread for each of these objects. So now we say thread t1 or whatever name is object name, whatever name you give, equal to new thread, and then in this new thread you are passing your dog object. That means your dog object is getting his own lane. Okay, how about if you have multiple dogs and each dog maintains his own track? So whenever like people do like marathon race, maybe at the beginning 1000 people start, right? And at the end there are few people only. Okay, but in Olympic games and other games, like for every participant there is a track, his own track, right? One runner should not exceed another exceed his own track, cannot go another runner's track, right? Track. So something so that we are passing this dog one to thread one, and then similarly we are passing dog two to thread two in another thread. Okay, now that there's a run method, we implement this run method. Actually, this is originally we actually rewrite or overwrite the run method, but the concept is that this run method is not called explicitly. We just call the start method. Start method calls the run method. Okay, start method will call the run method. So then we see that we will call t1.start, and then we set t2.start. So apparently, what do we think from this program? If we run this program, what do we think? That we think that traditionally the t1 object will be called first, and then its execution will be completed. Then t2 object will call the run method, right? And the t2 objects execution will be started. This is a naive or straightforward concept, right? But for multi-thread programming, it doesn't happen that way. So that you see that our program code says just it gave a track, the dog colon ID at I. That means which for I equal to, for instance, because there is counter 1000 counter, there are 1000 track, or so then what is doing? So there are apparently, if it is not a multi-thread program, then what would happen? The dog one will be executed first, then dog two will be executed. But here, if we look at the output, you see that what we see. So the dog one is at this number are coming randomly. Is there sometime? Do you see that output? Sometimes it's called dog one, and in between this dog two is coming. and then dog2, 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 in between dog1 is again coming. And then also we do not have the sequence, is not maintaining the sequence. Okay, if you run your program in your computer, it will come something like this, but not exactly this. Even if I rerun this program on my computer, it will not exactly same this. But the concept is that dog1 is running, and while running dog1, it will sometimes call dog2. And it will dog2 is running one, dog2 is running, it will be calling dog1. So ultimately there will be 1000 is a 1000 D1 object, and 1000 dog object will be on dog object. Sorry, dog1 object will be running 1000 times, and dog2 also will be running 1000. I'm sorry. In combination of dog1 and dog2, they will be running either dog1 or dog2 1000. It may be half of the time dog1 and half of the time dog2, or I don't know yet how many times each of these objects will be running. Okay, and run to run it will be different. Okay, so this is one concept, and then maybe this is a nice like a game if you are interested to develop a game. For instance, whenever we run a game, so there are dog objects created and dogs are running for a race. Okay, so here, so it's a class, is a dog object, is an array of dogs. So we make 100 dog object, and then we create new 100 thread, right? So then you pass one dog to one thread, and then you will see if you run this program. So we need one thing, the dog class we need to have, and then if we have this main method, and then you will see this output is coming, and which dog is on which at a certain point at which track. Okay, so let me see if I have my I can get it repeat. Okay, multi-threading example 1. C#. I should have more programs. Let me see. Let me quickly run this. So this is dog class, and this is main class. Okay, there is a issue. What is that one? illegal character at counter static. Okay, so the problem is that I have space. This space are making error. So I copy and paste the code. Sorry, this is a problem that if we copy and paste code. I have in my Eclipse, but my Eclipse is crashed. Okay, now still 3 errors, line number 12, 12 and 13. Line number 12. Okay.
I think you're missing a no, never mind.
No, there's a space, but okay. Just the empty space. There's a unformatted font. If you see that, doc2 are running, and then at some point it is coming doc1. See that? And then doc2 is running, and then doc1. Okay, so then while running doc1, you see that doc2 is coming. So that is like while running 1,000 dogs, each dog is not maintaining its own track because there are only 2 tracks, right? 2 lanes, and there are 1,000 dogs. Okay, so the 1,000, so 2 dogs, they are using 1,000 lanes. For instance, you can see that. So as which track it will be, okay? So I think you can easily convert this with C#. I will this one. Okay, this one is that one, and then another one I had here. I will discuss this, but I'm sending you the link before I forget. Okay. Okay, the same program in C#. Okay, I can write it in C#. This is my, okay, I already have using system, I already have this one. And then this the main method. Since I copied and pasted code, there will be some error maybe. Okay, that's good. It did not give us any error. Okay, so this is C#. Okay, similarly, you please practice other programs that it has. The slide has. The slide has another program. Which one? This array one, okay? Racing 100 dogs. You can practice this in Java, convert it in Java and C#, okay? So you need a dog class and then you need this one. So what do we need? Actually here, racing. True. Multithreaded. The dog example on Java. So you need the dog class. You need this dog class. And then in the main method, same problem that I copied and pasted code. There were some. Illegal character, line number 27. Where is it? So in this case, there are 100 dogs. Okay, in previous programs there were only 2 dogs, but there are here 100 dogs. Okay, these dogs are running. Okay, what is that? It's 1,000 times running. Okay, in 1,000 track. What is that one? Oh, these 100 dogs are using 1,000 track. So I'm giving this example. Okay, likely if you please complete the C# one. Okay. So then if you practice this, then I think you will get some interest that you are doing something. Okay, the C# code is here. Okay, just please copy and paste that. Okay, now there are 5 stages of thread life cycles. Okay, so there is a quiz questions from here. There will be some quiz questions. So one is the newborn state. and there's runnable state, running state, blob state, and date state. In my previous lecture, I discussed this. Whenever you just create a state that is in runnable state. Okay, a runnable state when you start a state, a newborn state, then it becomes two positions. Either is runnable or running. Is running, that is currently running, and runnable means is ready to run. So either two of this state you can postpone, okay, or so then you can postpone this runnable or running states, okay, and then later you can resume this. Or when a state is postponed or suspended, then you can either kill it or you can resume it to rerun it. Okay, so the combination of runnable and running state, the position of runnable and running state, this is called active states. These two are active states. Okay, so mainly you can say new state, active new thread, active thread. This last one is idle thread, and this one is killed thread, dead thread. Okay, so there are some built-in methods in order to execute, in order to change a thread position to these states. Okay, in all of the programming languages. So far we learned that we call the run method start method. And start method itself calls the run method. Okay. So there is a get name method. This is a getter method. It returns the name of the thread. So in your previous program, you can update it. You can at any time you can use get method to get the name of the thread. And then we use the start method to start a thread. We use start method to start a thread. But you notice that we never call the run method. We never call the run method. The start method itself calls the run method. Okay, then run method, and then these are the run method, sleep method, EL method, join method, is alive method. Okay, let me see, a few more slides are there, but this is the actually this figure they may get this, and then a game. For instance, when you develop, is there anyone here game development major?
Yeah, I am.
Okay, so then please, if you are intended to major in game development, please understand this module clearly. Okay, you will need this. So this is for instance, a part of a user interface of a game. So then, for instance, then you see that this different color are showing the different state of thread. So especially when you develop a game that multiple players play, that is multi-threaded game. Okay. So in most of the many games there are multiple players, right? So then you need to understand this. And there are some other concepts like synchronization. Synchronization, how to synchronize the thread or update the thread. Sometimes one thread may send result to another thread. Okay, in that case, there are some methods and built-in and some process, but we are not discussing those in this module. Okay, so the last one. What is the name I gave it? Wow. Sorry. I'm sending you this one. Sorry, I renamed that one. Okay, so let me do this one quickly. This is my top class. And this one, not this one. There are 112. Okay. This other one. Okay. Yeah, you please complete this one. Okay. So I will go. I have to go to another slide quickly. Okay. So we just went through module 1, part 1, thread, and the part 2 is parallel processing, and then part 3 is more about parallel processing. Maybe I will not be able to complete it tonight, and then in our next lecture I will go through parallel processing part 3. Okay, so I have my lecture video from my previous lecture. I can share with you. Okay. So there are only few slides. Let's see. So parallel processing, that we learned that parallel processing is the concept of that we will split a problem in multiple subsets, and we will execute the subprograms. Okay, and then at the end we merge the results. So like divide and conquer method process. Have you heard the concept divide and conquer? Divide a problem in two parts and then execute two parts differently, and then for each of the parts subprograms again divide until you get a smaller part that you can quickly execute and then combine the result. Okay. So when you do parallel programming here concept, one thing is that is called Moore's law. So Moore's law is that there is a mathematician, his name is John Moore, and maybe he in 1960s he just predicted a concept that he predicted that within every 2 years, is it every 2 years or 4 years? This will be a quiz question. Okay, so okay, he said every 2 years the capacity of circuits, okay, will be doubled. We know that, like what is that called, chips, memory chips, right? So when you use a cell phone, for instance, for cell phone, let us take a cell phone. So a few years ago the cell phone like iPhone have like 4 or 16 gigabyte memory space. Then it became 32 gigabytes, right? Then 64, then 124 gigabyte, then 256 gigabyte, right? Then now 512 gigabyte memory. Okay, and then one terabyte, right? It's coming, the 2 terabyte, it will come this way. So that John Moore, he predicted that the increment of the capacities per square inch in the integrated circuit. Integrated circuit will be double in every 2 years. And then he, at that time, like mid-60s, he predicted that the trend would continue then 50 years from that time. Like he predicted that until 20th century. But now we see that this trend is still available, right? Still it is increasing, and still I don't know. We don't know actually yet where that will end, right? So every time we see that the memory speed or processor speed or memory capacity, these are increasing, but the cost is decreasing, right? Competitively, right? Competitively, phone cost is decreasing. Like 2 years ago, like 10 years ago, when iPhone or other phones like smart devices introduced, they were more costly compared now, but they were less efficient, right? Okay, even if we have a computer like 10 years older computer, you see that that is more costly than more speedy computer right now, laptop. Okay, so I think please read these slides. Please read these slides sometime, and then you will need this for your some quiz questions. Maybe you will get it from here. Okay, so then I don't have anything here I cannot show you, because one thing is that I did some parallel processing task with CUDA language, and then it needs another virtual machine, but I don't have set up the virtual machine in my MacBook, so I cannot show it. So for each, you see the parallel dot for each, it is used for parallel processing. This for each, parallel for each, is used to do parallel processing. How can I show you one thing? So the concept of parallel processing, okay, so that you have multiple. So you have a problem, you have a large problem, for instance, and you split the problems. You split the problems in multiple parts and subparts, and then each part you send to, okay, so send to one thread, on thread, and this one will go here, and this one will here, this one will here, this one will here, this one will here, like in multiple threads. Okay, so then in regular for each for loop, then here it says that it takes only one thread, it executes. But in parallel processing, what it does, so it takes multiple processor, it takes multiple threads, and they run together concurrently. This is the concept. I don't have time today, but it is not the concept for this course. You have something. GitHub. Okay. But this is not the part of this course. I'm not going to discuss this. I have some programs and then result. We did it for parallel processing. Okay. What else? So it says parallel dot for each. We don't need this maybe for this course, okay? For this course. Okay. I want to spend 15 minutes. Maybe I can spend 15 minutes more. So let us do quickly, if I can cover the next topic, more on parallel processing. Actually, parallel processing too. Actually, this is my own slide. I give while I came here for job interview. I give this presentation in 2018. Okay, so parallel programming with fork join task in Java. So as we learned that, so Java has a way to create multiple threads, right? By either by extending the thread interface, thread class, or by implementing the runnable interface. Okay, there is one way to that is a way to do multi-threaded programming, but it's parallel programming. Parallel programming, what it does in parallel programming, there are more than one processors, and then each processor processes its own task. You see that this is the concept of parallel programming. So there is one CPU and the process one. The CPU2 is process 2 is sent to process CPU2, and process 3 is sent to processor or CPU3, and then process 4 is there are multiple processors. So almost these processes are identical, and then processors maybe they are local processor or they may be in distributed computer. Okay, so Java has its own way so to work with parallel processing. Okay, one of the this is called Java thread pool. Okay, Java thread pool that is available since Java's first version. Okay, this is one of the naive way, and there is another way. Java has executor service in Java since it is available from version 5. There is a better way. So in the executor service, you see that there are tasks. The main task is divided into some sub-tasks, and there is a task queue. So that is the task queue contains some task, and there is a thread pool. So in the thread pool, gets the task from the task queue. This concept is little bit more faster than using thread pool. So thread pool were used previously. Now people use executor service. But recently, in Java 1.7, like a few years ago, Java implemented a fork join pool. There is a little bit better concept than Java executor service. So on the executor service, you see that so there is a queue, and then on queue, the tasks are coming over here, and sometimes they are waiting for long time. Okay, so in order to resolve that problem, what has happened? So in the fork join pool, a task is divided into subtasks and subtask, and then after some point it will be small enough to execute quickly, and then whenever it execute quickly, the result are merged. The result are merged or joined, and finally these are the circle are the results. So result are combined or joined to get the final result, and these are done parallelly with multiple threads. Okay, so the picture, this one is here, or just is large font over here. So task, then so fork in split into subtask, and then subtask again until we get a small task, and then when we get a result, combine the result, join the result. Okay, this is the concept of fork join pool. Okay, so the fork join pool actually it uses divide and conquer fashion. Okay, divide the task into subtask, and concurrent means combines the result. Okay, so parallel programming this is the pseudo code of parallel programming using Java fork join pool. Okay, let me show you. So the two main methods is one is called fork, another is join method. In the fork join framework, Java fork join, there is two main methods. Two methods. These are widely used. One is fork. The name infers that the fork is used to split the task, and join is used to combine or join the result. Okay. The concept is something like this. So parent program, the Mult program is again, so it is fork and then joined, fork and join. So this is the fork join task. Okay. So I have a live program. I will show you how it is used. So find the Fibonacci series or factorial of a number. So what is the Fibonacci series? Okay, it could be a good intuitive way to show the fork join implementation of parallel processing with Java. So if the Fibonacci series, okay, Fibonacci, we discussed Fibonacci series, maybe, right? Fibonacci series is a mathematical series that every third number is the sum of previous two numbers, right? In the Fibonacci series, we know that the numbers are like this. For instance, start with 1, the second number is 1, the third number will be 1 plus 1, 2, fourth number will be 1 plus 2, 3, the next number will be 2 plus 3, 5, the next number will be 3 plus 5, 8, the next number will be 8 plus 5 plus 8, 13, then 21, and so on. Okay, so now if you are asked to find a Fibonacci series, like a Fibonacci series, or for instance you say that we want to find that this is what is 1, first, second, third, fourth, fifth, sixth, seventh, 8. So if you say I want to get 8 Fibonacci numbers, 8 Fibonacci number, 8 Fibo number. Okay, what 10th or 9th Fibonacci number? Then we know that the 8 Fibonacci number is the sum of its previous two numbers, right? And this number is the sum of its previous two numbers. So instead of executing this in one single thread, or instead of executing it in single processor, it would be nice if we can execute this in multiple processors. At least you can try with 2 processors. Okay. So for instance, if you want to get the fourth Fibonacci number, so then we divide the fourth in 2 fork. In one side, we will find we know the fourth Fibonacci number is the sum of third and second Fibonacci number, right? So then if in one side, in one fork, in one side, if you can find the third Fibonacci number, in another side, if you find the second Fibonacci number, and then quickly you can add them up to get the fourth Fibonacci number. And similarly, if this side is still again, one side is still again larger, then you can split it again. Right? So this is forking, and some point when you get the result, then we know that this is a base cases recursive method. For instance, first Fibonacci number or second Fibonacci number, these are the base cases. Then you can combine the result and to get up and quickly get that result. Okay, so the concept of creating, I have a few more slides. Okay, the concept of creating a Fibonacci a fork join pool is that we use fork join pool. This class is a built-in class, and then we create an object equal to new Fibonacci number, and then you submit a task. You submit a task to the Fibonacci object using invoke method. Okay, that's it. Okay, for the test, you will not be asked to write this code. Okay, just to give you demo so that you get some idea that it is possible to how do we do parallel computing. Okay, don't worry, please keep attention for the next 5 minutes. I think 10 minutes I will finish it. Okay, so this is a complete program. Fibonacci number. Okay, so this is a complete program, and then this is the execution result. Okay, so if I will come with the execution result like this. Let me go to it quickly. If I do have the code, CD. Okay, so I have my program. Actually, my program is that here. If I go to my repeat account, so for join parallel processing with Java, I can share this code with you. Okay, so if you are interested in, you can practice this. Okay. Okay. So one thing is that, but for this program, the execution is different. Okay. This is the source code. You have the source code over here. This same source code I just showed you in this slide. This same source code. This source code here. This is the source code, but we need to run it. So you see that we are creating Fibonacci class by extending the recursive task. It is a recursive method with parallel processing. Okay, so now I will show you how to run this program. So I'm in the fork join poll. Anyone here has idea about how to use GitHub? You know GitHub? Do you use GitHub? Yeah, GitHub is a good thing. So everybody please be familiar with GitHub. Okay. Then ultimately you will need to use it. You will learn to use it. Okay? But if you learn right now, you'll one step ahead. Okay, so I see that what is my code. I have src folder, cd src. So if I split, let me open it here on the left side in the workspace. Fork join poll pp, and then this is src. So src folder, you see that I have, let me do it side by side. Okay, so you can see the effect. So like 20 years ago, when I wrote my first Java book, I compiled Java program using like this. At that time, we did not have Eclipse IDE. We wrote program on Notepad. There was no Notepad++. Then we wrote the program in Notepad, and then we compile like this way. I will show you that how to compile. Actually, this class file will be generated. So let me delete this class file. Okay, only the Fibonacci, my Fibonacci class Java. So so give attention about here. Okay, so I'm doing parallelly. I'm showing it myself. So here see that I am in this folder. Okay, so I have only Fibonacci.java class. Then how do I compile this Java class? I said Java. Oh, I'm sorry. I said Java. I'm calling Java compiler. Okay, then I will write the class name Fibonacci.java. Fibonacci.java. Notice that, okay, only my source folder currently it has only Java file. Okay, that is created on February 18, 2021. Last semester. I updated last semester. Okay, then as soon as I click over here, just enter. If there is no error, that it created the Fibonacci class. It's just created. You see that today, few seconds ago, right? So even if I delete it right now again, and then if I run this code again, and then it will be creating again. You see that. Okay, now I got this Fibonacci class. Okay, now this program is another example of This is another example of running a program on it's called command line. Okay, so far the program that we discussed, the main method, the all main method have, you see that the main method has an argument, right? String type argument. So at this time, this is an example that we are using this argument. So this argument is an array type, string type argument. So in this program, while I run this program, I will pass argument to this main method. Okay, the argument, you see that first time argument 0, the first argument I will be passing. So this is an array, the array have first argument. I will be passing, this is an integer, and then Fibonacci of. So for instance, Fibonacci was maybe 5th Fibonacci. For instance, I want to find the 8th Fibonacci number, okay? And then second argument I will pass how many times I want to find that Fibonacci. For instance, I said 10 times. I want to get the 8th Fibonacci number 10 times. So now the question is that why I am asking, I'm doing same Fibonacci number more than one time. What is the logic? There is a logic. Give me 1 second, please. You will understand the logic behind why I want to do that. Okay, so here now I will run the program. How do I run the program? This time I will call Java interpreter, just Java, Java, not C. And then I will call the class. So for the call class, I don't need to write Java or Java class. And then I will pass 2 arguments. First arguments, I want to get the 8th Fibonacci number, and I want to get, for instance, 10 times. I want to get the value of 8th Fibonacci number 10 times. So the first argument is passing which Fibonacci of 8 Fibonacci number, and the second one how many times. Then if I run this program, you see that my output over here, okay, you see that my output, it runs 10 times. You see that it runs first time, second time, third, 4, 5, it says 10 times. But you see that on the right side, it is giving me time, how many milliseconds it took. But for first time, 8 Fibonacci number is 21. 21, right? Did you 21, 8 Fibonacci number? 1, 2, okay, I did a mistake. So this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 one is this one. Actually, this one 8 Fibonacci number, not this one. So 1, let me double check. 1, first, second, third, fourth, fifth, sixth, 7, 8. So 8 Fibonacci number is 21. Okay. So 8 Fibonacci number 21, but I got 8 Fibonacci, I calculated 8 Fibonacci number 10 times. Why? The reason is that I want to compare in which run how much time it takes. You see that for first run it takes 16 milliseconds. Do you see this? In the first run it took 16 milliseconds. In the second run it took about 1 millisecond, right? In the third run it took still less time, and the fourth run it took a better, it's a little bit more, okay? And the fifth and sixth and seventh, and then every time it takes different time. Okay, so if I run this program again, so I have code here, right? If I run the program again, so I will get a different again and the different timing. So this time is taking 17, this is 1, 1, 1, and then this is less than 1, right? And this is maybe way less than last time, 10. Can you predict what is the reason that I'm getting different timing? Do you have any idea? Have you got any idea why I'm getting different timing?
The executions are just finishing differently on The different threads?
Yes. So execution are so actually is that we discussed that our threads are so here, for instance, we wanna get the 8 Fibonacci number. Okay, so 8 Fibonacci number. Okay, we wanna get 8 Fibonacci number. So we know that 8 Fibonacci number is the sum of 6th and then 7th Fibonacci number, right? So, and the 7th Fibonacci number, it may have that in one side, it get 5, and in that another sense, it may get 6. Okay, and then maybe in 5, it may get in 4th and then 3rd, right? And the 3rd, it will get at one side, maybe a second, and then first. So whenever you get first, we know the first Fibonacci number will return 1, and the second Fibonacci number will return 1. This is the base cases. Okay, but if my splitting is like something like this, right? So then it is nice. But if I have my splitting is like this, on one side, it in one wings we are splitting the number. So we don't know how it split is. If it is guess one side is second, in another side, it gets, for instance, 7th. Okay, and then in another side, it gets maybe, for instance, if you see the 5th. And another side, it gets maybe first. So if there is a balance, good balance between the thread, okay, the branches, so there will be a good timing, less timing. But sometimes it may have this imbalance. Okay, then that will not be good timing. So we don't know yet. We are not looking there internally how is it dividing. So that will take more coding. But we see that the first time it takes 17 milliseconds, and then one time it takes less than 1 millisecond. But we run same program with same thread with same processor.
I have a question.
Yes.
Will run 1 always take significantly longer than the rest of them?
I don't know. So that is a good question because I don't know. We don't have any guarantee that how it will be running. So apparently you are right. It shows that run 1 is taking significantly more time than other. But there's good. You have a good observation. You see that if I run maybe multiple times, maybe it is taking a long time because these data are coming on processor on the front of the memory. They're getting quickly. But actually, in order to get this, so if you get more Fibonacci number, maybe 18 Fibonacci number 10 times, you will see the result is taking this large number. You see that it takes 24 milliseconds and it takes only 2 milliseconds sometimes. So again, this is the concept of parallel programming. I'm lucky that I was able to finish it today, but you may practice. Okay, I gave you my. Did I give you my code? Did I give you my code for design? Okay, so if you are interested in, you can clone my project and you can do some practice. But again, it should not be in your test question. Okay, I will let you know if there are some questions from here. Okay, but hopefully will not be. So you will not be able to do it with that practice. Okay, so this ends parallel processing. Okay, I wish I could get maybe a little bit more time because we spent some time in your test to review. Okay, but there was only one. So how was your test too? People who are joining online, how was your test too?
Should I be concerned that I finished it in 15 minutes?
Sorry? Say that
Should
again.
I be concerned that I finished it in 15 minutes?
You could not finish in 15 minutes? Or what is that? Yeah, are you talking about test 2?
Yes, test 2. I was saying that should I be concerned if I finished it in 15 minutes?
So really you finished in 15 minutes, you said?
Yes, yes.
That should not be a problem. It's good.
All right.
That means you practice the problems, right? That means you practice
I guess so.
Okay, but you master the concept, right? You understood well, right? The concept?
Yeah, definitely.
Okay, that's good. Thank you. Okay, has anyone any other question? Okay, hopefully you will get your test result in 2 weeks, okay? Has anyone another question? If you don't have any question, then thank you so much.
I don't have any questions.